Okay, we're gonna freestyle some adding and subtracting rational numbers. We'll see how this goes. So if you don't know what a rational number is right off the top, please go to my chapter 1 video, Understanding Rational Numbers. I don't have time for that. So we're just going to talk about adding and subtracting. So the first thing we need to do with rational numbers, obviously rational numbers include negative numbers, and negative fractions and negative decimals seem to be the part that people struggle with the most. So the first step is decide whether each number is positive or negative. Okay, so what I mean by that is 3 minus 6. 3 is positive, it doesn't have a value, and 6 is negative. So we have different signs here, and we'll get to that in a second. When we have these 3 plus a negative 6, this is just the same exact thing as subtraction, only we're showing it as adding a negative. So what I have people remember, if nothing else, is plus. This right here is what I call weird, because we don't know. This is plus minus. It can't be both. So it's either plus, or it's either positive or negative. So we have to decide what it is. So plus a minus is minus. Minus a minus is plus. And believe me, I know that this is not mathematically correct language, but it helps people remember. So plus a minus is minus, minus a minus is plus. So you could have 4, let's do negative 4 plus 6. Again, these are both different signs. The 4 is negative, the 6 is positive. And so now we know that they are different signs. We could also put negative 4 minus a negative 6. This again is the same thing. So this right here is the same as this, because minus a minus is just plus. So these two things and these two things are equivalent. They are the same thing. So I have looked at this and I have determined that it is plus. I have looked at these two things and determined that it is minus. So now we sing our song. And I'm not going to sing it on here because that will be official YouTube content. But the same signs add and keep. Different signs subtract. Keep the sign of the bigger number, then you'll be exact, right? So in both of the cases, the sign is different. So 3 minus 6, different signs subtract. 6 minus 3 is 3. Keep the sign of the bigger number, then you'll be exact. The other one was negative 4 and positive 6, and so different signs subtract. Keep the sign of the bigger number, then you'll be exact. 6 minus 4 is 2, not 6. And then the 6 is bigger, so it's positive. Okay, so that's step 1. Determine whether it's positive or negative. Step 2, if you're taking notes here, which you should be, is sing the song. Okay, and understanding rational numbers it's very important that you kind of get the hang of understanding why this works. For instance, same signs add and keep. Well, if I start at negative 5 and I go more negative by 5, those are both negatives, so they are same signs. I go more negative, then I am getting a larger negative number. Therefore, I add and keep. Okay. So now let's get into fractions. Okay, so it's the same thing. So we're going to have, let's do a simpler one. Okay, so step 1, determine whether each one of them is, what sign each one of them carries, okay? The first one is negative. Negative 1/4. The second one is plus a minus, so we've got the weirdness. Plus a minus is minus. So I can rewrite this and then basically just forget the top. And now I have a negative and a negative, so I have same sign, so I'm going to add and keep, but I'm just going to kind of come over here and I'm going to add. Now, when basically my rule is I do it horizontally, which means I'm going this way when I have just a basic fraction, and when I get to ones like 3 1/3, 2 1/2, 20 1/3, I stack them, and we'll do that in a second. Okay, so we're gonna go. So with fractions, we need a. So you deal with the negatives. You determine if you're going to add or subtract them, okay, and what the sign is, so that kind of goes together. And then you always, when adding and subtracting, need a common denominator. Okay, I'm trying to not make this an hour and a half, so I'm hurrying up. So we have the common denominator between 4 and 2 is 4. They are common multiples. So if you don't know how to find the common denominator, they are the common multiples. Multiples are 2, 4, 6, 8, 10, 4, 8, 12, 16. Those are the multiples of 2 and 4. So if we see what is the least common, I always go to the smaller number and say 2, 4, 4. So 4 is our common denominator. I didn't need to do anything to the first fraction to get from here to here. But on the second one, I had to multiply by 2. Therefore, I have to multiply this top one by 2. So I end up with 2/4. So now I'm left with this new problem, which is 1/4 plus 2/4, which equals 3/4. Okay, so now I check my negative. That's something new we have to do. So remember, we did same signs, add and keep, and both of our signs were negative. So the answer, let me erase that. So the answer is negative 3/4, and I like to circle my answer. Okay. All right, so I'm going to quickly escalate this. So what happens if I have 3 1/8 negative 3 1/8 plus 2 1/4. Okay, so this is where I would stack. So first of all, I'm going to deal with the negative. I'm going to determine whether it's adding or subtracting. Okay, so these are different signs, right? This one is negative, this one is positive. So they are different signs, so I'm going to subtract the two numbers, keep the sign of the bigger number, right? The bigger number is negative, so I already know I'm going to have a negative number. Now, 3, and this is when I do my stacking, 3 1/8 minus 2 1/4. Okay, I still need a common denominator. So my common denominator, I look at my smaller one, and I start thinking of the multiples of 4. 4, 8, 8, right? 4 goes into 8, so 8 is 8 times 1 is a multiple, and 4 times 2 equals 8. So 8 is so I'm just going to, over here, I'm going to make this an 8, and I had to multiply this by 2 to get there, so I multiply this by 2, and this one stays the same. Now, hopefully you notice this is a problem. I cannot take 1 minus 2. It's just as if this were 31 minus 22, I couldn't do this, right? I would have to borrow, correct? And I borrowed from the tens place, so I added 10 to my 1 here, and it became 11. So over here, I'm borrowing from my ones place. So if I borrow, actually, let me undo that. Let me use a different color. If I borrow from 3 and make it 2, I just borrowed 1. But in order to add 1 to my eighths, to my 1/8, I need a common denominator, just like any other problem. So how many eighths make 1? Well, 8/8. That's 1 whole, right? If you have 8/8, you have 1 whole. So this new thing, excuse me, I'm going to have to erase so I can make some room here. That is going to be 1/8 plus 8/8 is 9/8. Now I can take 9/8 minus 2/8, 9 minus 2 is 7. 7/8. Okay? And now I just look here at my whole numbers, and 2 minus 2 is 0, so I'm done. But I need to remember, keep the sign of the bigger number. So I always tell people to have a healthy fear of the negatives. You need to make sure, go back and look at the problem, make sure you have accounted for the negatives. And the reason why I teach this, yes, you could have done this a different way. The way we would do this is we would have to change these into improper fractions, where we would have to take 8 times 3, which is 24, plus 1 would be 25/8. And then we would have to subtract from it, let's see, 5/4, because 9/4, because 4 times 2 is 8, plus 1 is 9/4. And I would subtract those, and I would get, let's see, brain's already not working, 16, or, yeah, I would get 16. Sorry, my brain obviously not working here. Oh, I'm sorry, I would have needed to get my common denominator. Let me just go to my point, because I'm taking too long with this point. Okay, so I could do this, and this actually wouldn't be that hard. I get common denominators. This one would get kind of large, but what ends up happening that I don't like is what happens if this number here is 233 and this number here is 112. These numbers get huge, especially once you get to the common denominator. Next thing you know, you have 2,000 minus, and then you're trying to simplify that. The stacking method always works, and this is the hardest part. This borrowing is the hardest part. So, okay, so one more. Let's talk decimals. So decimals are probably the most straightforward in adding and subtracting. You can kind of take a deep breath and relax. So again, we're just going to figure out, we're going to deal with the negatives. So we're going to figure out, actually it would probably be better to change your notes back to figure out the sign, sing the song to figure out if you're adding or subtracting. Figure out the signs, sing the song, and then for decimals, we just line up the decimals. And don't forget, note, the greater value goes on top. What I mean by that is when we get to multiplication, the one with the most digits goes on top. But if you have 3.14 minus let's see, 6.1, okay, different signs subtract, okay, so keep the sign of the bigger number. So when I go to set this up, what a lot of kids want to do is put 3.14 on top minus 6.1, and you can't do that because this one is the greater value. So that would be wrong. I've already caught at least 4 or 5 kids getting answers wrong because of that. So the greater value, which is 6, has to go on top. Okay, so 3.14 goes below it, and where this empty space is, I add a 0. So that now we're lined up, and we're going to subtract the two numbers with the greater number on top. That's a 10. We borrowed from this, it became 0. We borrow from this, and it goes to 5 and becomes a 10 here. And 10 minus 4 is 6, 10 minus 1 is 9. My decimals stay lined up, and I end up with 2.96. Now we have to fear the negative a little bit, so we look back up here and we say different sign subtract, keep the sign of the bigger number. Bigger number is 6, so the sign of the bigger number is negative. All right, so that is hopefully helpful with adding and subtracting. If you want some more one-on-one, or if you want to work through some problems, I highly recommend that you, if you're still struggling with this, that you re-watch this and take some notes that make sense for you. So you're going to figure out which signs which. Sometimes you have to fix fix the weirdness, as I say. Then you have to, once you figure out, okay, this one is positive and this one is negative, or these both are negative, then you're going to sing the song. Same signs, add and keep, different signs, subtract, keep the sign of the bigger number, then you'll be exact. So that's just determining whether you're going to add or subtract, right? And which sign to keep. Little hint, if you always keep the sign of the bigger number, you will always be right, because same signs are obviously going to keep the sign. So, and then with adding and subtracting of decimals, line up the decimals, the larger value goes on top. All right, I'll try to get another video out soon with multiplication and division. They have a whole new set of rules. Luckily for us, multiplication and division is a little easier. So thanks, and we'll see you next time.